This is an object detection model I trained from scratch, detecting different types of sign language signs in real time. But this isn't just any old object detection model. This uses a unique algorithm and deep learning architecture called DETR to simplify training. At least that's what the paper said. After training my first sign language object detection model over 4 years ago, I wanted to give it another crack, given the tech is advanced and some of y'all are finding some slight dependency issues. I'm going to show you how to train your own from scratch in under 40 minutes. But where and how do we get data? And don't deep learning models need massive GPUs and months of training? And will this work fast enough for real-time detection? I love reading scientific papers, especially when they hide critical training notes in a single nondescript sentence. This was interesting to get up and running, and my training notes definitely tell the story, but I've sunk weeks into this to make it easier for you. The first step, making real-time detections with pre-trained weights in under 5 minutes. Alrighty guys, we are back to sign language object detection. It's been a couple of years and a couple of dependency issues, but I've gone and rebuilt the entire library completely from scratch using a DETR architecture, and there's a whole bunch of setup instructions and all that inside of the GitHub repo, but I'm gonna get you up and running ASAP. So I'm gonna copy this link here, and what I'm gonna do is I'm gonna clone the GitHub repository. So if I go git clone, and then paste that link in there, so it's https://github.com/my GitHub repository, /sign DETR, and hit enter. This is gonna clone. Let's give that a sec. Boom, that's all cloned. Now what I wanna go on ahead and do is jump into that folder. So we can do that by running cd SignDETR. My head's blocking that. Cool, so we're now in that folder. You can see it there. Let's just clear this so it's back at the top. And then what we want to do is we want to open it up inside of a new VS Code instance. I'm going to say code dot, and this means that we're going to have all of the stuff that we need to get up and running just on the left-hand side. I'll quickly run you through this. I've got a bunch of images and trained labeled data up in the data file inside of pre-train. I've got a set of checkpoints that I trained for 4,426 epochs. It took roughly 24 hours, but I did it all on my MacBook. So no GPUs outside of what's available here. So you'll be able to run this yourself. Inside of the source folder, there's a ton of stuff, but I'm not going to bore you with all of that for now. What we're going to focus on is the real-time file. Now, if I scroll on down, you've got the ability to go and choose which camera device you run this on. So I've got mine set to device 0. If you get any errors, maybe try changing that. Let me know in the comments below, I'll help you out. Okay, but for now, let's get this up and running. So this is all done using UV. So if you don't have UV installed, you can run pip install UV. I don't need that because I've got it installed on my machine. But as soon as I go and run UV run source realtime.py, so running this file, it should kick off real-time detection. Now, what I'm going to do is I'm just going to bring VS Code over here because I've actually gone and set up some really interesting logging. So if we go and run that command, it's going to install all of the stuff we need to get up and running, and it's going to kick off real-time. Let's give that a sec, and then we should see real-time detections. Alrighty, and we have real-time detections up and running. Now, again, you can see that we've got some interesting logging over here. So I've gone and built up this library and I've called it, let me zoom out a little. Oh no, it's screwed up the text. Doesn't matter, I've called it NODDY. You'll see it print out a little bit more nicely a little bit later on. But down here, you've got some really interesting information. So you can see that it's specified the name of the model, the number of classes, the hidden dimensions. Again, we'll go into this once we start training our model. But down here, you can see the inference time, so how fast it's making predictions, as well as the frames per second. And over here, this is the real-time detection frame. But you can't see anything. That's namely because I don't have my hands in the frame. As soon as I do this, take a look, we are making real-time detections. And you can see down the bottom left, we're actually getting those results printed out, and it's really, really quick. So again, this is running on my local machine. There's no GPUs here. If I go and change to I love you, so we've got 3 classes that we're going to be predicting. Hello, I love you, and thank you. But take a look, it's running ridiculously quickly. So you should be able to get this up and running on your machine. If you need to go and change the device to pick up a different camera, you might need to do that. Again, let me know in the comments. But now that is our real-time detection up and running. Now this works pretty well for my big head, but what if lighting conditions were different, where you're making detections, or you're a different person? Well, we're going to go on the journey to train your own. The first thing we're going to need, data. Hey guys, just quickly, I also went and made this cheat sheet that I went and uploaded to the GitHub repository after recording this entire video. Hopefully it helps you get up to speed a little bit quicker. I really hope you're enjoying this video. If you are, give it a thumbs up. It really helps the channel and helps the video. Anyway, back to the coding. Right, so what if you wanted to go and get this fine-tuned on your own data? So we're able to go and do it for me, but what happens if maybe this isn't performing so well on your data or on your own face? Well, how do we go and fix that? Well, this is where fine-tuning our own model comes in, or training our own model. So I'm actually going to stop this now and clear that, and we are now going to get into the nitty gritty. So let's quickly double back and actually take a look at the files that we've got available here. So we've got our pre-trained weights over on the left-hand side. We've also got logs, which it starts kicking off once you've got the inference running. But right down here, you've got a ton of information. So I've got a data file, which actually loads in the data using the PyTorch data class. And again, I'm not going to go through a massive deep dive in this. My goal is to get you up and running. If you want a deep dive, let me know. And maybe we'll do like a 1 hour or 2 hour deep dive into this. The loss function, which uses a special algorithm called the Hungarian matcher or linear sum assignment to be able to go and train the model. We've also got the model in and of itself. It's got some interesting embeddings, and then the ultimate DETR architecture. You can see it's all built inside of PyTorch. All of the details are over there. We get 2 prediction heads. So we get the classification, so what class it's detected. So hello, I love you, or thank you. But then we also get the prediction boxes, which allows us to draw that on the frame. Real time, you've already gone and seen. Test allows us to go and test out our predictions on an image. Train is what's going to kick off our training run. But for now, what we're going to do is we are going to double back and get some data established. So if I open up this data file, I've got 2 folders, train and test. We're going to replace these in a second. If I open up train and open up images, you can see that I've got a bunch of images. These are the ones that I actually use for training, right? So from scratch, it's all here if you wanted to go and see it. And I've also got the labels. These are inside of a format called YOLO. So basically we've got the center coordinates. So I think it's X, Y, and then width and height. And you can see that the number at the front corresponds to the classification. So this one is I love you, thank you is 2, hello is 0. So you can see those there. That's so tiny. I don't know how you're going to be able to see that, but there you go. Okay, cool. Now what we're going to do is I'm going to teach you how to go and collect your own data, and we're eventually going to train on your data, and we're going to label it all. So I'm going to run you through all of this. Again, all of these instructions are inside of the GitHub repository, but we're going to go and take it step by step. Okay, so I'm just going to close all of these files. What we first need to go on ahead and do is collect some images. Now, I've gone and created a utility that allows you to do this. And again, it's got cool logging. So if I actually go to utils and then collect images, it's all here. Now, again, if you need to go and change your camera device that it picks up, so right down the bottom, you've got this ability to go and change this device here. So if you go and change the device that we send to capture images, that's going to change the camera. You can also choose where to put the data, and we're going to capture train first. So I'm just going to say train here, and you can choose how many images you want to capture. So we're going to capture 30 images per class. That's what this is saying over here. So if you wanted to capture 40 images, you could do that. If you wanted to capture less, you could do that. I think I tested it out with 10 just before. It worked okay. Okay, enough of me blabbing. Let's go and collect some images. So I'm just going to bring this over to the side so you can see it, because it's going to pop up a camera, and we're going to get some logging as this happens as well. So let's make this a little bit smaller now. And what I'm going to do is I'm going to clear this. And what I'm going to do is I'm going to kick off the real-time capture. So to do that, we can go in UV run source. Let's make this a bit bigger so you can see it. Source, utils, and then / collect images. So that's going to kick off that collect images flow. So if I go and hit this, it's going to start pretty immediately. Take a look, you've got NODDY, so I'm just going to capture hello. So that's all the logging. And down the bottom, you can see that it's capturing hello classes. So I'm just going to move my hand about, and we're going to collect images. We're eventually going to label these. You can ignore the text in the top left-hand corner. It's going to eventually remove that. I've just included it to make it a little bit more obvious what class we're capturing. Okay, so once we get to 30, we should switch to I love you. Oh no, we're collecting 40. Okay, boom, I love you. So you can see it's transitioned down here. So I love you is going to be this sign. And again, you could obviously go and change the signs. And transitioning thank you now. Perfect. All right, so you can see that we've gone and captured all of our images down here. We're just going to do the same for, actually, let's just validate that we've gone and done that successfully. So I'm going to open this up. And so if you now go into the data folder, and if we go into train, you can see we've got all of these images now over here. So what I'm going to do is I'm actually going to delete the existing labels and images folder inside of train, and we're going to replace these with hand labeled data that you're going to do in a second. So, or I'm going to do in a second, you're going to see it. I'm going to do the same inside a test, and we're going to collect some test images while we're at it. So let's delete those. Okay, so let's go on ahead and jump back into our collect images file. So over here, so remember we've gone and put it inside of train to begin with. We're just going to put it inside of test now. And let's only collect like 5 images per class because I don't want to be labeling forever. So I'm going to change the number of images down here. Okay, so this, if we go and run this now, let me go and bring that over to the side. And we're going to do it again. So if I go and run, UV run source utils collect images.py, it's going to kick it off again. So hello, go on behind. And if you screw up like I just did there, what you can do is you can just jump back into the folder, right? So I'm just going to delete those images that I captured because I wasn't able to see what I was doing. So I'm just going to delete that. Stuff breaks, guys. You thought this was all going to go perfectly. Okay. No, it is. Okay, so what I'm going to do is I'm just going to clear. So I couldn't see the camera, so I couldn't see what was happening. So if I go and run UV run source utils collect images.py, ideally try to keep the camera in front so you can see what's happening. So, all right, so I'm going to bring this up. There we go. All right, collecting images for hello. And now I love you. And remember, we're only collecting 5. And then thank you. Okay, perfect. Those are our images now collected. So if I go into our folder, under test, you can see that we've got all of our images. And you can see that we don't have the text in the top. Could probably remove some of these images. Let's just quickly scan through. That's hello. That I love you is kind of crap, so I'm just going to delete that image. That thank you is a bit average as well. Let's delete that. All right, the rest looks good. Let's jump in a train, do the same. I'm just going to speed through this. Okay, so those are all of our images now captured. I've also gone and done a quick review, removed anything which wasn't all that great. Now what we need to go and do is label them. So effectively draw the bounding boxes on those. I used to do this using a library called Label Image. We're going to be using Label Studio, which is the new version. Now, inside of the source folder, I've got a file called config. This basically dictates what order the classes need to be in. So hello, I love you, and thank you. Maybe we'll extend this out later on, but for now, we want to try to mimic this order. Now, inside of the pyproject.toml file, I have a dependency called Label Studio. So we're going to use Label Studio to be able to go and label our images. Now, this should have installed when you went and ran the real-time capture. So what we can go on ahead and do is run UV run. Let me make this bigger. UV run label-studio. And this is going to start it up. Alrighty, it's gone and opened up on my other screen, but let me bring it up over here. All right, so it should look a little bit like this. Let me zoom out a little so you can see it. Originally, you won't be logged in. So if I log out, what you can do is go and sign up for an account. It's all local, so you don't need to pay anything. It's completely free. I've got my default account details in there, but if you go and sign up, you've got the ability to go on ahead and do that. I'm going to log in. And what we're going to do is we are now going to go on ahead and create a project. So over here, you can see that I can create a project. We are going to load up our data. So if I hit create project, what we're going to do, let's make this a little bit bigger. So I'm going to name this sign language YouTube, and we're going to call it the train partition. So this is going to be where we load up our training images. And then what we're going to do is hit data import, and we're going to upload our training images. So if I hit upload files, I'm going to jump into my desktop and then go into my YouTube folder, SignDETR. And then remember, we saved our data inside of data and then train. So this should have all of our images. Take a look. All of them are there. So I'm going to select all of them, hit open, and those are all going to upload. Oh. Okay, so it turns out you can only upload 100 images at a time. You'll learn something every day. So I'm going to go to upload files, and I'm going to start from here. And then maybe let's just do each class one at a time. So if I go to thank you, and let's find the end of thank you up to there. Okay, so let's upload those images. Perfect. Then if we go upload more files, then we'll do I love you. So we'll go from I love you to the end of I love you over there. Boom. And then let's upload what's left. Hello. So if we go down to the bottom, boom. There we go. Okay, now we've got our images uploaded. All right, so that's our images. We then need to go into the labeling setup. This is where I was sort of telling you the config was reasonably important. So if I minimize this, so remember we've got our classes. So hello, I love you, thank you. Let me show you how to get this into the labeling studio. So over here, what you need to do is select this template, which is object detection with bounding boxes. So we're going to choose that. And then what we'll do, and let me zoom out a little so it looks a little bit more obvious. So you can see that we've got two labels set up here, airplane and car. We're going to get rid of those. And we're going to add in our own custom labels. So our labels are going to be exactly what we've got here. So hello, I love you, and thank you. So we'll go, hello, I love you. And if you just added in a new line, it'll go and create all of them at the same time. So hello, I love you, and thank you. And if I hit add, boom, hello, I love you, and thank you. And the order is really important because that's the way that we're going to train, and that's the way that we're going to label them when we go and do real-time detection. So you can see we've got hello, I love you, and thank you. And right down here, you can see we've got the label numbers. So 1, 2, and 3. Perfect. Now, if I go and hit save, you can see that we are now ready to label. So if I go and step into my first image, I can now go and label. All I need to do is choose the class. So I can do this on my keyboard by hitting 1, 2, or 3. I can also just select it down there. So I'm going to use the keyboard. So this is an example of thank you. So I'm going to select 3, and then I'm just going to draw the square. Boom. And then to enter, I can either hit submit down there, down here, or I can just hit command return on my keyboard, or command enter. So if I hit submit, that's going to submit it. If I go to my next image now, let's try doing it with the keyboard. Command enter. Okay, I'm going to speed through this because we've got a bunch of labeling to do. I'll jump back in once we're at the next class. So let's go and do thank you. Okay, that's all of thank you done. Now I'm going to do I love you. So I'm going to hit 2 on the keyboard and keep on going. All right, we're on to hello. So all of the thank yous are done and the I love yous are done. So I'm just going to hit 1 on the keyboard so you can see down here and do hello. Let's keep going. Okay, those are all of the images now labeled. So if I scroll on through, you can see that they're all labeled. So all we have to do now is hit back into the project. And then over here, you can see that there is an export button. So we're going to hit export and then scroll on down to YOLO with images. So we're actually going to download the annotations plus the images again. And we're going to get rid of the images inside of the train folder because I think it relabels them or renames them inside of Label Studio. So I'm going to hit export. Boom, that's them downloaded. Let me just open up a Finder file. So if I go into downloads, you can see that I've got project 9 over here. And if I open it up, look, we've got images and labels. And if we go check our classes, we've got hello, I love you, thank you. So what I'm going to do is I'm going to copy images and labels. And then I'm going to jump back into my SignDETR folder and then go into my data folder and then into my train folder. And I'm actually going to select everything there and then delete it and then paste in our images and labels folder. So this contains all of our images. Beautiful. And you can see it actually appends this text at the front, which is why I just download the images and the labels again. Okay, cool. So those are all of our annotations. You can see that we've got all of our YOLO annotations. Beautiful. You can double check that this has worked. So if I actually go into my source and then data file, so over here, this will actually preload some data and show you what the data will look like after we've gone and done all of our transformations. So similar to what we did in the vid video, I actually do a bunch of transformations so that we don't need like thousands of images. Right now it's pointing at train. If you want to point at test, you can. Remember, we haven't actually got an annotated test as of yet, but I just want to show you to validate that this has worked. So if you go and run the data file, so if I go and run, let's actually leave Label Studio up and running. I'm just going to open up another terminal. If you go and run UV run source, and only do this after you've actually gone and annotated and pasted the images back inside of the train folder. So if you go and run UV run source data.py, this is going to show you an example batch. If I go and hit that and run it, it's opened up on my other screen. Let me show you. So that's what an example batch would look like. So you can see that we actually go and change the brightness, the hue, and we actually go and do random crops. And I've actually gone and implemented like a specific safe transform so that there's always a bounding box available within the image. It just makes training a lot easier, avoids a whole bunch of errors and tweaking the loss. So if I go and run it again, it's probably going to open up down here, and it did. That's another batch. Okay, so that effectively tells us that we've gone and successfully annotated our training data. Now what I want to go ahead and do is do this on our test data. So we're going to repeat exactly what we did inside of Label Studio, but we're now going to use our test data. So if I jump back, so remember we had all of our images inside a test. It's way less, thankfully, but we do need to be careful with this, right? So we need to make sure that we have the annotation labels in the same order because we want to make sure that we have the same class numbers. So I'm going to jump back into Label Studio and I'm going to create a new project. So up here, And then what I'm going to do is I'm going to call it, what do we call the last one? Sign language YouTube train. So this is going to be sign language YouTube test. Cool. Then we're going to go to data import. We can upload all of the images in one go. So I'm going to jump into my data folder, into test, grab all of these, boom, bish, bash, bosh, then go into label studio. And then we're going to go into the object detection with bounding boxes again. We're going to get rid of these labels and what was the order that we had it. So if I jump back into my config, hello, I love you, thank you. So we're going to go, hello. Let's make this a little bit bigger so we can see it. Hello, I love you, thank you. Beautiful. And then add those. Cool. Then I'm going to hit save and we're going to do the exact same thing. We're just going to start labeling. So let's go on ahead and do this. Okay, those are all of our images labeled. We're just going to jump back into the project, do the same thing. So I'm going to run over to export and we're going to export YOLO with images and then hit export down the bottom here. So that's our project now downloaded. I'm just going to jump back into, while we're inside of the test folder, let's just delete these. We don't need them anymore because remember we downloaded the annotations plus the images. So if I go into downloads, I'm going to copy this project. Actually, let's open it up. Jump back in and then I'm going to grab images and labels. We'll go back into our folder where we're working. So YouTube, SignDETR, data, and then test, paste those there. Okay, now if we want to go and validate that we've done that successfully, if I go into data, and then this is something interesting that I've implemented as well, right? So if you want to disable those training augmentations, which means that we don't need as much data. So first up, what I'm going to do is I'm going to change the images that I bring back. So I'm going to bring back test. And then you can set train equal to false here. So it's not going to apply all of the crops and all of that random stuff. So if I go and run it again, so if I go and run uv run source data.py, you'll see that it doesn't have all the random crops and all the weird colors. So if I go and run this, and this is going to be on our test data now as well. Let me show you. Take a look. That's what it looks like after we've gone and normalized the image, after we've gone and shown the annotation. So that is an example of what we're actually going to get back in our test data, but that is also our data now prepared, ready for training. So in stage one, we loaded a set of checkpoints I had on GitHub. When you teach a model using the data you've collected, you're going to get your own model weights that are personalized for you. How do we do this though? This brings us to step 3, training the model. Okay, so we've now gone and successfully collected our data ready for training. So it's time to actually kick this thing off. Now I'm going to again keep this pretty concise in terms of what I'm going to show you. So if we go into the model.py file, this contains everything that you need about the model, right? So it includes a couple of different sections. I'll quickly run you through this. So first up, we've got the sign cos positional embedding for the data that we're going to be passing through, which is mainly the images. Then if I scroll on down, this is the core machine learning or deep learning class, right? So down here on the forward section, you can see that we're actually going to be running the data through a couple of different components, namely a backbone layer, which is supported by ResNet 50. So you can see I'm loading that there. So effectively, this forms like the underpinning of our DETR model. And then we pass it into our other fine-tuned layers, which is where the transformers come in. So once we've passed it through this backbone layer, we then go and extract all of those features. We apply a positional embedding, and then down here, it gets sent through to our transformer, and then we get those 2 prediction heads. So we get our classifications, but we also get our boxes as well. And then if you wanted to go and test it out and actually see the model, you can actually go and run this. Let me show you. So if you go uv run source, model.py, it'll actually show you the model architecture. So let me make this a little bit bigger. So this is done using torch info. So it actually shows you, I think I showed you this inside of the vid tutorial as well. So you can see that we've got our DETR model and then we've got the ResNet architecture all the way over here. We then have a convolutional neural network layer, a bunch of layer norms. It then gets sent to our transformer, which has an encoder and decoder architecture. And then down here, you can see our final number of trainable params. So it's 26.9 million parameters. Now, again, if I scroll on a little bit further, you can configure all of this. It just means that you won't be able to use the pre-trained weights. But let's say that you wanted to go and increase the number of transformer heads. You've definitely got the ability to do that there. So over here, I've given you the ability to go and change the number of transformer encoder layers, number of decoder layers. Batch first is equal to true. Don't change that because I've gone and structured all the data components to operate that way. If you had more classes, eventually you could go and extend this out. Maybe we'll do a deep dive or do like a whole object detection crash course, but that is the model. The other core component is the loss. So this is composed of 2 key components. So the Hungarian matcher, which is linear sum assignment. So basically, when we actually go and build up this DETR model, one of the unique things about it is that it outputs a number of queries. Think of these like predictions as to where the boxes are. But what we need to do is we need to assign these to our actual predictions. This is where the Hungarian matcher comes in, and it tries to find the closest distance between our predictions and some of those queries that are coming out of our DETR model. We then use a number of different loss metrics to go and compute the final loss, and we assign those predictions to those queries. We calculate that loss, and then we get our final output. Down here, you can see a really good example of that. Also, if you go and search linear sum assignment from SciPy, so I'm actually using it in here, there's a really good breakdown. I think I've actually left a utility in there. Yeah, so when I was trying to understand this myself, I included a little bit of an example. So play around with this. It's inside the utils file. It's called linear sum EG. Okay, but enough of that for now. Let's actually go and train. So if we step into train.py, everything that you need to go and train this model is in here. Now, we'll give you a couple of options. So over here, if you wanted to go and use the pre-trained weights that I've already gone and trained, you can choose to load these or not load these. So if you comment it out, it's not going to pick up my pre-trained weights. If you do leave it on, it is going to pre-train with those weights. It just means that you're going to train a lot faster, ideally. If you wanted to go and speed up training, you can increase the learning rate or decrease the learning rate. I'd highly recommend using that learning rate. I'll give you a quick snippet as to my training logs as to how long it actually took to get to these parameters, but this tended to work. You can assign different weightings to the different loss components. So we actually get 3 different loss components. We get a classification loss, and this is determining what box it actually is. So is it I love you, hello, or thank you? We then get the B box weighting, which is actually predicting the coordinates of the box. So coordinate 1, 2, 3, 4. And it's effectively a regression task. So we're effectively trying to see that we're positioning it correctly. GIOU is generalized intersection over union, and it has an area component. So it's almost like introducing geometry into our loss. So basically what we're trying to see is that our box overlaps or our predicted box overlaps our actual box, and it's trying to reduce that loss to make sure that we're predicting the correct area. So this one is more coordinates. This is focused on area. The rest is all down here. You can also change the number of epochs. If you wanted to train for a lot longer, you could bump this up. I trained initially I think I set it up for 10,000, and then I cut it at 4,000 because I didn't see it getting much better. But by that point, it was already performing pretty well. Everything else, you can sort of take a look. Again, if you want to really deep dive into this video, maybe we'll do that. But for now, let's go on ahead and kick off our training. So because we've already got all of our data all set up, all we need to do is kick it off. If you had your data in different locations, you could change it here. So I'm pointing it at train and test. So those were our 2 partitions that we've already gone and set up. All that's really needed to do now is go and run this. So again, I've tried to make this as straightforward as possible. So if we go and run uv run source train.py, this is going to kick it off. Take a look. I've included some really nice logging, and down the bottom, let me hide myself. You can see that if I scroll on up, we've got NODDY, which stands for Nick Object Detection. I don't know what the DY stands for, but I wanted to call it NODDY, childhood cartoon that I used to like. We've also got some dataset statistics, so we can see our dataset path for our training partition. We can see our data transforms that are being applied. This is all inside of the data file. We've got our test details. We've also got our data transforms. Again, it's just repeating that. We've got information about our model, so our number of classes, hidden dimensions, attention heads, encoder layers, trainable parameters, and down the bottom, you can actually see the model training. I'm just going to zoom out a little bit so you can see it a little bit better. But take a look. So we can see our progress across all of our epochs. We can see our final train loss, our test loss, which gets computed once we've finished running through our train batch. And then we've also got the elapsed time on the far right. So there you go. That is our model now training. So let's let that run. It's going to save checkpoints every 10 batches, or every 10 epochs. So again, you can go and configure this. I'll show you where that is. So if I go into the train file, let me minimize this for a second. If I go right down the bottom, you can choose how frequent you want to save. So right down here, it's saving every 10 epochs. If you wanted to go and change that, you've definitely got the ability to go on ahead and do that. It also saves a final set of checkpoints, and you can also change where it's going to save. Actually, this is currently running at the moment, but I haven't actually created a checkpoints folder. So what I do need to do is make sure that we've got a checkpoints folder. Otherwise, it's not actually going to save. I wonder if it's thrown an error. Hasn't thrown an error. Let's just make sure that we've got a checkpoints folder. Perfect. Okay, that will make sure that we go and save our checkpoints. So once we get to epoch 10, which should be coming pretty soon, we'll see some checkpoints pop up. Okay, take a look. We've successfully gone and trained for 10 epochs. And you can see that we've got our output here. Let me make this a little bit bigger. It doesn't like being zoomed in, does it? Let me zoom out. All right, so you can see that we've successfully gone and output our data over there. So we've got our checkpoints. You can see that that is all successfully running. If I go and open this up, you can see that under the checkpoints folder, I've got a checkpoint called 10.pt. So you can see that we've successfully got our first set of weights. And eventually I'm going to show you how to actually load these up and run them. So for now, let's just let this go on ahead and keep training. And I'll see you once we're done. Alrighty, and that is our model train. Now, I wanted to sit there for that entire training run for the montage, but I needed some snacks. So we are back though, and we have successfully gone and trained the model. And if we open up on the left-hand side and go and take a look at our checkpoints, if I scroll on up, take a look, we've got all of our checkpoints saved up there. So we've got 10, 20, 30, 40, 50, 60, 70, 80, 90, and 99, which is our final one. Now, if we go and take a look at our loss, you can see we sort of started out at around the 70s, the 80s, the 0.7s, the 0.8s. And by the time we ended, we were down into the 0.5s, 0.6s. We even got a 0.4 around there. Test loss kind of stayed the same, but remember, we didn't have much test data. So that could have potentially influenced that. Now, when I initially started training this completely from scratch, our loss was 5.1, 5.2. So again, this is significantly benefiting from having those pre-trained weights, but that is our model now trained. Now, there's nothing better than seeing visual results of your hard work. So it's time to test out some detections. We're going to test on our data set, but my personal favorite, we're going to end up with real-time predictions. Okay, we're on to my favorite bit, finally testing this out. So it's a lot of effort to go and collect all of that data, train it. So you ideally want to go and run this yourself. So I'm going to quickly show you how to test it out on the test partition as well as actually going and doing this in real time. So if we go down here to test.py, so it's under source and then test.py, what you can do is you can actually go and pass through your test data set here. If you had more data, you could go and pass through a different folder as well. So let's say you created a separate partition. Most importantly, you want to go and load in your own weights. So right over here under this line, so line 24, you can go and load in your own weights. You just need to pass through the path to it. So right now we've got checkpoints over here. So I can go and say checkpoints, and then we're going to pass through 99_model.pt. I don't know why I named it like that. I think it was from the vit model and then I just sort of stuck with it. Okay, so we're gonna load checkpoints 99_model.pt and see how we go. So again, this is gonna load in an image and run it on an image from our test partition. So to go and run this, we can go and clear all of our training logs now. We can go UV run source. Also, let me know what you thought of the logging. I spent a ton of time working with it. It was a little bit vibe coded, but I thought it looks really, really good. It sort of takes it that one step further. Okay, and should we make NODDY an official library? Okay, let's go and run this. So UV run source test.py. Let's see how we go. Okay, so the detections are on down here. All right, so we've got I love you. We've got hello, hello, I love you. That's looking pretty good. And in the box, you can see that we've got our predictions as well. I should just make this a little bit bigger. That is our test partition. So we've got I love you, hello, hello, I love you. If we go and run it again, over here as well, it's going to print out a bunch of information about what it's actually doing. So it's got NODDY popping up. It's got the data set stats, the data transforms, it's got the model architecture, as well as the prediction. So it'll give you the class, the confidence or the probability in this particular case, as well as the bounding box coordinates. Now, if we go and run it again, boom, it's popped up down the bottom again. So we've got, how do we go? So we got hello, that's fine. I love you, hello. Let's do one more. Do we get a thank you anywhere? We've got a thank you. Okay, you got a few thank yous in this one. Okay, so we've got thank you, and it's obviously pretty comfortable at predicting thank you. So thank you, thank you, thank you, thank you. Keep in mind, I had a different hoodie on when I pre-trained on that data, so it's clearly not picking that up. It looks okay. All right, let's go and test real time. So that's a bunch of images done. The real time's the best bit. So if we go to realtime.py, close this down, and remember, we just need to go and change the checkpoint. So we're going to say, we want to load in checkpoints, and then we want to load in 99_model.pt. Boom. Okay, save that. Let's go and run this now. So UV run source realtime.py. So all I did there was I went to line 31 and I just updated the checkpoints path. So this is going to load in the checkpoints that we've gone and pre-trained or we've gone and trained. Again, you can go and load in different checkpoints. If you wanted to load in 90 or 60 or 10, or even load in my pre-trained ones, you could go and do that as well. Let's go and do real time. So if I go and hit enter, actually I want this on the side because this always looks cool, doesn't it? Okay, so let's move my hand. So down the bottom, so we've got, let's actually rerun it again. So we get some nice logging. I think the logging, it doesn't respond all that nicely to being compressed down. So maybe if I zoom out, did it screw up Noddy again? Yeah, it screwed up Noddy, that's fine. Okay, all right, so we've got our frame over here. How are we doing? So if I put my hand up, boom, hello. Boom, hello. All right, so look, that's our that's a model that we've actually gone to train. Maybe if I move the mic out of the way, how are we doing? Pretty good. What if we do I love you? It's picking that up. Might be low confidence on that one. All right, so take a look. So we've got I love you. It's also going to only return, let me bring the mic back. It's only going to return predictions that are over a certain threshold. I'm going to show you how to change that as well. And boom, thank you. So hello. Maybe doesn't like the mic too much. Hello. I love you. Thank you. Boom, we are running. So also just on that little bit about predictions, so I added in a flag in here. Let me scroll on down. So over here, it's going to limit anything that's below 80% confidence. So if you wanted to go make it more strict or less strict, you could do that. So if I dropped it really low, right? So if I say 0.6, because right now this model will predict 25 object queries. So if I go and run this, it should go crazy a little bit. Let's go and run it. No, it's still only got one. That's pretty good. Not too bad. There you go. I surprised myself. So I think when I originally trained it and I was pre-trained, there'd be like 25 boxes on the screen because they were all just low confidence. Hello, I love you. Thank you. Oh, that works so nicely. And there you go, guys, that we've successfully gone and trained our own sign language model. Hopefully I've made this a little bit easier for you guys to go and train this yourself. Let me know what you thought of the DETR model and the NODDY library. Hopefully you enjoy this and you're able to go and get your path started on your way to becoming an AI absolute gun. Anyway, thanks so much for tuning in, guys. Let me know what you thought of this in the comments. I'll catch you in the next one. Bye.